So what I just gave you is a gift. Do with it what you will. If you want to use this for basically what I just gave you is a flow chart of the notes. If you want to throw this in the garbage, throw it in the garbage. Some people find this really useful. Some people find it, kind of a waste. Top 4, I really wouldn't worry about it, but basically what it says is if you see an angle side angle case, it's automatically one solution. Start solving it using law of sines. Same with angle side. Side, side, side. Yes, we'll do law of cosines tomorrow. Side angle side. We'll do that with the law of cosines tomorrow as well. The big one. What is happening here? Is this recording?
Recording.
What is it recording with?
Just recording before.
I feel like if you would like record your hands on.
Just hit the record button. You're welcome. Yeah.
Okay, record video.
What is happening with my computer right now?
Now you have to record it.
It's
I'm
like
like double.
virtual. Isn't it?
I don't know.
Hit the
square on the top left.
Top left? Oh, cool. Well, I want it to go away. I want it to stop recording. What did I hit to even do that? There's no record.
Wow.
Oh, there's the record button. Oh, I didn't even know I. Cool. Okay, shut up. Okay. The main part of this that you guys want to look at is this part. Okay? Now remember, for this whole diagram, just like the notes yesterday, anytime you see a capital A, the angle A, what does that actually just refer to? The given angle. So if angle A refers to the given angle, then little a would then refer to the side opposite of the given angle, right? And then little b refers to the adjacent side. Everybody understand that part? So there's 3 scenarios. If you run into the ambiguous case, angle, side, side. Well, if you have an obtuse angle, it's easy. Just check. Is the biggest side opposite the biggest angle? If it's yes, one solution. If it's no, no solution. If you have an acute angle and the side opposite is the bigger side so far, automatically one solution, start solving. The one you want to be concerned with is this one over here. Angle A is acute, and the side opposite is the smaller of the two. Remember, the one that you need to be concerned with is this scenario here, where you have an acute angle, you have an 18 here, and you got a 16 here. This is worst case scenario. You have an acute angle, side opposite is the smaller of the two. If this is the case, then you have to do a test. What does the test determine? How many solutions? It's not going to help us solve the solutions yet. It's just going to tell us how many solutions there are. Okay? So the test is the B, or the adjacent side, times sine of the angle. Remember, you're always going to compare this with the 16. Right? We need to know, is this 16, remember, think of it as it's swinging down, is this 16 too short and it's not going to reach? Or is that 16 long enough and when it reaches, it'll actually reach twice, right? So that's the scenario. Is everybody good with the flow chart? Does this kind of make sense? It's purely for your notes. If you like it, use it. No, you don't get to use it on the test kind of thing, but if you, there's a lot of things that I should let you do, but I don't,
At least me and Derek usually let.
Just you and Derek?
Yeah.
The week. That does make a lot of sense.
I mean, you know, we're pulling everybody else's grade now.
It's kind of, you know, it's kind of an equality thing, you know. We got to help you a little bit more to keep it
Hey,
even.
if you're doing that, I'm jumping on their bandwagon. I haven't used this question.
Shut up, Jacob.
Me too. Me too.
I mean, how many weakest links can we have in the class,
Oh,
though?
you can use the.
There's that.
At some point, we just have a bad chain, you know. Okay.
You know, if you let us cheat a little bit
Yeah,
more,
one bad name,
we get you a better name.
All right, so, guys, here's our goal today. Number one, understand. So there's 4 things I need you to understand with this whole scenario. Number one, recognize when you're going to have a problem. I think that's easy. Everybody understands if it's angle side side, you have a potential problem. The second thing to understand is, all right, once I know that this is a bad scenario, how do I determine how many solutions there are? Okay? That's the test. We're going to go over that in a second. The third thing I want you to understand is why there's a problem. What is actually causing this entire angle side scenario? Like, why is this a special case? Why is this a problem? The fourth thing to understand with this is, all right, if there is 2 solutions to this, how do we find both sets of solutions? So let's do this problem. Everybody grab a calculator. So we got to do our test. We saw, and this would be my line of thinking here. Oh man, this is angle side side. Oh, it's an acute angle, and the side opposite is the smaller side. That means I have to do the test. What I'm hoping for, because we all hope for less amount of work, right? What I'm hoping is this 16 is too short, right? Remember, when you do the test, what you're actually calculating, all right, this thing can go away now. How do I close this? What?
You don't have to be rude about it.
You know, sometimes I just want people to go away, but I don't get my way either, so. Remember, when you do the test, what you're actually calculating is that height, right? When I type in my calculator, make sure I'm in the right mode, what I'm actually calculating is that height. So 18 times the sine of 40. What I'm hoping for is a number like 17. Why? What would that tell me? There's no solution, right? Well, what I get is 11.5, which is less than 16. What does that mean? Is this 16 big enough? Yes. And if it's bigger than the height, what does that mean about how many solutions I have? That means there are 2 solutions to this problem. Okay? Now, as soon as you establish that there are 2 solutions to this problem, here's what I would want you to do. So our problem is 40. What was this? This was 16 and 18? All right. Whoa.
You're doing it again.
I know. It's funky sometimes.
Just keep dropping there.
All right. Let's put some letters in here just to keep things consistent so we can actually solve it. The second you realize that there's 2 solutions, here's what I want you to do. You write down ABC, ABC, and put in the given information. You got a 40. We know side A is 16, and we got side B is 18. When you finish that list, how many solutions is this? That's 1 set of solutions. What we actually have to do is double that, which means we got to do a second set. But the second set are going to have all the same given information. So the 40 will be the same in both, the 16 will be the same, and the 18 will be the same. So that's really the goal here, is we have to find 2 separate triangles. You good so far? Say that one more time.
So when you get the height, you just go off.
No. Let me show you how you do this. All right. Where's my pair? Let's start solving. Sine of 40 goes with 16 as the sine of B goes to 18. This right here, this proportion, every single time you have an angle side-side scenario, you're going to have this same basic proportion. This is actually what's causing the entire ambiguous case. Because when you type this in your calculator, and by the way, look what I've already typed in my calculator. This was the test, right? The test is actually always the first part of how you would solve this. What do I type in my calculator? 18 times the sine of 40. I've already done that because that was the test. The test is always actually going to be the first part of the butterfly, little time saver. And then divide by 16. And then what? Inverse sine. This step that you are taking the inverse sine of a number, this is actually what's causing the whole problem. Because how many solutions are there between 0 and 360 anytime you take an inverse? There's two, isn't there? Like that's a fact that we've established all year long. When you take an inverse, there's two answers to this, right? Think the triangle going around, sine's gonna equal, just as a quick review. I think this one, nope, that's not what I want. I want that one. Remember this fun little gadget? There's two different spots. There's a spot over here somewhere that sine is going to equal 0.72. And then there's a spot over here where it's going to equal 0.72, right? Like there's multiple angles where that's true. So the question becomes, what are the two answers to this proportion? Well, one of the two answers, when I inverse sine that, is 46.3. What other quadrant? Now I'm doing the inverse sine of a positive. What two quadrants is sine positive? First and second. How do I get to the second quadrant? 180 minus. So I'm going to do 180 minus that angle. And the other answer to this is 133.7. What that means is there's two answers to this proportion that both work. So that tells me one of my angle B's is 46.3. The other angle B is 133.7. The first proportion, when there's two solutions, the first proportion is what's going to give you both B's, or the first angles. Now, how do I finish this triangle? What has to be true about these three angles? They have to add up to 180. What has to be true about these angles? They also have to add up to 180, right? And I do another law of sines, so now I can go 180 minus 40, or that's just 140, minus, and then this is one thing I do love about these calculators, is I can go up and grab the 46.3. Try to never type in a rounded number. Because if you use a rounded number to calculate another number, what's going to happen to your next answer? It's going to be off, right? So now, I think you should round your final answers, but while you're calculating, try to never use a rounded number to calculate another number. Does that make sense? Now, technically speaking, that 46.3, even by using the whole thing, it is a rounded number, but it's rounded to like 10 decimal places, so that's pretty darn accurate. So my first angle C should be 93.6. And then how do I find my other angle C? I do 180 minus 40, which is 140, minus, and then I'd go up and grab the 133.6 or 7, and I got 6.3. Does that kind of make sense? How would I find this other missing side? I just got to set up another law of sines. And now my other law of sines would be something like sine of 40 is to 16. As to solve this one, I can do sine of 93.6 is to C, right? I can butterfly that. I can throw in a 6.3 here instead of the 93.6, and I can find the other missing side. Yeah, you're doing twice as much work for one problem because you got to find two full solutions. Sorry, there's no fast way of doing that. The good news is the next problem might be no solution and it's super fast. So I think by understanding why this whole ambiguous case is caused, I think it helps understand how to solve it. Because the mistake people make is they forget, all right, I found the first angle B, how do I find the other angle B? Well, it's always going to be that first proportion that you set up that gives you that other answer, okay? And don't be surprised when you see some really weird angles like this. Like 6.3, that's super small, isn't it? Well, if you think about the whole ambiguous scenario, come on, why can't I go back? Let me go back. Okay. If you think about this whole ambiguous scenario, where this side here is smaller, if it's not much smaller, like this side is not much smaller than this, you know, one triangle is going to be kind of normal looking, right? The other triangle is going to be kind of messed up. You know, it's going to be a super tiny little angle, like 6 degrees. You're going to have a big obtuse angle. So don't be surprised if that happens once in a while. It doesn't always have to happen. If this side was a little smaller, you know, it could even be as much as, you know, there's one triangle here and one there. Those two triangles, you know, aren't much different from each other. Where, you know, it kind of really depends on how close in distance these two sides are. Where now that one's really kind of messed up and then pretty big. Does that make sense? So, how are we feeling about this stuff? Decent? Let's try one more. Let's make sure we got this.
Okay, we're feeling terrible.
Huh?
We can't do homework, feeling terrible.
Yeah, we're doing homework. Might as well just start it. Let's just start it together. Everybody take a look at page 166. 166. Practice exercises. Oh, by the way, ignore the directions where the directions kind of say, well, don't even know about that. So, number 2. And I would just do this. Number 2. A, B, C. A, B, C. They give us, what, 71? They give us a 37, and they give us a 40. And yeah, it would be helpful to draw. So we got angle 1 is 71. Right? No, the quiz and test are going to basically look identical to this homework assignment, where it's just going to be ABC, ABC, ABC. I don't want to draw pictures. You can draw pictures. You're a smart kid. It's just easier to write that stuff. All right. So what's the thought process? Oh, man, it's angle side side. Oh, and it's a acute angle. And the side opposite is the smaller of the two. What does that mean? That means you have to do the test. This is worst case scenario. I have to do the test. So the test is 40 times the sine of 71. Remember, you're always checking to see, is this 37 big enough or is it too small? Okay? So what is 40 times the sine of 71? 37 point what? 8. Well, that's bigger than 37, isn't it? What does that mean? That 37 is too short. There is no solution to this problem. Done, moving on. Now, by the way, here's another way to approach these. You can forget about this whole flow chart if you want to. You really can. You could go with the assumption that every single one of these has two solutions. You could just say, I'm going to assume they all have two solutions. And I'm going to try to find them. What do you think would happen if I tried to find a solution that doesn't actually exist? Weird things will happen. You'll get errors in your inverse sines. You'll get angles that add up to more than 180 degrees. You'll get sides that are the biggest angle is not opposite the biggest side kind of thing. Weird things will start happening and go, wait a minute, that's a triangle that can't possibly work. You could. Now, it's going to take you a lot more time to do it that way by assuming, like this one, if I realized I could just do a quick test to determine if there's no solution and I do that, all right. Or let's just try it. I have a pair, sine of 71 goes with 37, as sine of B goes with 40. What happens when I try to solve this? If I go 40 times the sine of 71, there's my 37.6. I divide by 37. I get an answer of 1 point something. What's going to happen when I inverse sine a number that's bigger than 1? Think about the sine curve. When does sine get above 1? Never. Doesn't it peak at 1 and then it starts to come back down? There's no answer to this. It's going to say error. Why is this saying an error? I'm not doing mathematically anything wrong here. I set up my proportion perfectly. I typed it in perfectly. Why am I getting an error? Because I'm trying to find a triangle that doesn't exist, right? So something weird should happen. If there's one solution, and you assume there's two, what do you think is going to happen to that second solution? Something haywire is going to happen. Your angles will be, bigger than 180. You'll get, you might get something a little bit smaller here, which makes this one a little bit bigger. And what would happen if this was 143.3? Would this work? No, because 40 plus 143 would already be over 180. That's not going to work. Something funky would happen with the second set of solutions if you're trying to find a solution that doesn't actually exist. Does that make sense? So, you could do it things that way. I think you're just going to create more work for yourself by doing it that way. And you're not really understanding why there's problems. Good? Try number 4. Number 4? What's number 4? So they got angle A is 29. Side A is 15. Side B is 19. So,
Are we doing every second problem?
yeah, we're doing the evens. So the homework is 2 to 28 even. So, what is that? So they gave us a 29, a 15, and a 19, right? Oh man, it's angle side side, which all of these are going to be. Oh, it's an acute angle. And currently the side opposite the given angle is the smaller of the two. What does that mean? I got to do the test. And the test would be 19 times the sine of 29. We're comparing that to 15. We don't know if the 15 is too big or too small. So 19 times the sine of 29 comes out to be 9.2, which is less than 15. What does that mean about the 15? That means it's big enough, right? That means there's two solutions. So the second I realize that, I'm copying that. And yeah, I always get the question, is the given information going to be the same? Yeah, that's the whole idea. Like, I got two different triangles with the given information. That's all going to be the same. What's my first proportion? Sine of 29 goes with 15, as the sine of B goes with 19. How many answers are there to this proportion? 2. Remember, it's going to be 2 as soon as you do the inverse sine. So I do 19 times the sine of 29. Notice it's already in your calculator because that was the test. It's always going to be the first part of the proportion. So then I divide that by 15. And then I inverse sine. So I get B is equal to 37.9. So B is 37.9. What should I immediately do? 180 minus. Is it always going to be 180 minus? Yes. Why is it 180 minus? Well, that's because of the whole inverse sine thing, first and second quadrant, and then it's 142. Remember, the first proportion that you set up is going to give you the first two answers. Okay? It's because of the inverse sine. There's two answers to that inverse sine. One in the first quadrant, one in the second quadrant. Well, how do you always get to the second quadrant? 180 minus. So yeah, it's always going to be 180 minus the first angle you find. How do I finish this? These three angles have to add up to 180, right? Do another in-law sines to find side C. These three angles have to add up to 180. So, then do another law sines to find that. Yeah. This one's twice as much work. The good news is the last problem was almost no work because there's no solution, so it kind of balances out in the end. Okay?